Hi. So a lot of people have been asking, how is the bike doing? Because obviously we made this months ago. In fact, I'm not actually sure when we made it. But the bike is still here and it's running fine. And I want to give you a close-up of it and talk a little bit about it. Now, of course, I'm not really interested in the bike. The bike is just a toy, really, and it's a lot of fun. I mean, we're still driving it up and down, particularly in the summer. And it's running just fine. We've charged and discharged this battery, and to be honest, I have no real idea how many times, over a dozen, something like that. But we use it to go shopping with, and we use this battery as we would use any battery, really. Now, this is the battery we actually made all that time ago. And it's all a bit homemade and a bit scrappy. And it took us ages to make it, obviously. And I'm going to show you the battery. It's been living in here, and it's a bit dusty. And there's not a lot to tell about it, because obviously it's a battery, so it's just one big old square box. But that's the battery that took us about, I don't know, a month to make, something like that. Maybe even longer than that, actually. But that's the battery that's been running this bike for the last few months or so. And it's still going strong. Now, there's no real point in asking about performance metrics of this battery. I haven't been measuring it. All I'm really interested in is having this battery in place, using the bike, and seeing how long we can use the bike for in a reasonable way, for however long. That's all I'm really interested in. There's no performance metrics on this battery per se. We reckon it's around about a kilowatt hour, something like that. It does run this for about twice the distance the previous battery was supposed to run it for. So it does really well. It doesn't take that much looking after, and we've done nothing to it, which is awesome because that's the way it should be. Now, in a black box, there's not a lot to tell, so I'm going to go back to the bench and show you what's actually inside that black box. That black box doesn't tell you anything particularly. It's like a battery. It's not really exciting. It's just a black box. Ooh-ah. And the question is, what's in that black box? Well, obviously, we made an awful lot of sheets in that black box. And what's in there, essentially, is this stuff. This is stainless steel mesh. It's a really fine grade, and that's what we use as the collector plate, in fact. And we've got about 400 metres of it here. So we work through this stuff at a rate of knots, because this is what the stuff that we use to make batteries with. Now, what we do is we use this machine. And this is a fantastic machine, actually. It's a tab welder. So there's the little spots there. And we take a little piece of our mesh. And in the case of the box, they were A4 size pieces, and here's a little 10 by 10. So it's been a while since we did 1 centimetre squares. We do 1 centimetre squares to do all the chemistry of it, because we want to see how the chemistry behaves, and we don't want to spend years doing it. We want to get it as quickly as possible, so we do centimetre squares. After we've done centimetre squares, we do these 10 centimetre squares, because this tells us more about how the battery is going to behave before we go to a full scale. Because obviously we're doing this stuff by hand, and if I have to make a battery like that one in the box, that takes months of this stuff. We actually hire people in to do things like paint it, because it's really, really boring. But anyway, we take these 10 centimetre squares and use this tab welder on it to tab on a little stainless steel strip. Now these strips are really important because the mesh actually sucks the electrolyte up. And if you try to connect to the mesh, what happens is the connection corrodes. It sets up a galvanic potential between the two. The electrolyte corrodes the thing, and it very quickly dies. So what we need is something that the electrolyte can't creep up, and something that will weld nicely to that and not form a difference in potential. So we put a little stainless steel strip on it, and then it's spot welded on. Now this little welder here was actually amazingly cheap. I think it was £180 off of eBay. I'm not expecting great things from it. I'm not quite sure how long it's going to last, but it lasted long enough for us to do all of this stuff, and I'm really quite pleased I got that, because it made such a difference to the performance of the battery. Now, batteries aren't so much to do with the chemistry of the battery. Actually, the chemistry of the battery adds very little to the battery. What's really important in the battery, and what you're going to find when you make your own batteries, is the structure, the construction. Stupid, stupid things will make a big impact on what you're actually doing. And batteries can quite often fail for the dumbest of reasons. I mean, you look at what happened to Samsung with their exploding phones. The reason their phones exploded was because the separator they put in there was a little too short. So when they made the battery and compressed it, the negative, positive, anode and cathode were compressed into touching, created a short, and the whole thing exploded. It was a dumb thing. Just tiny little bit less separator and this touching. Now we had the same problem actually, because when we were using these things, what we did was cut them out with scissors, and it's a mesh. So what it did was create thousands of little needles on there. Now the separator we use, I'll just get it for you. Is this stuff. This is Celgard 3506. It's an experimental separator from Celgard, and it's about 16 micrometers thin, so it's really thin stuff. And if you imagine those little needles on that thin bit of separator, what they were doing was punching through and shorting out the device, and we didn't really realise that until ages. So we were working with this thing, wondering why the hell it wouldn't keep its energy, and then it suddenly struck, oh, that's why. And so I put a bit of fiberglass in there actually, which is about 1 millimetre thick, and suddenly it was cured. And it made me think, oh, okay, we've got to find something to do about these little sharp edges here. So construction in your battery is really an issue. You've got to work out how you're actually going to construct it. Now, a lot of people say to me, why have you been working on this so long? And I think, really? Really? We've been working on this for about 10 months. There's 2 of us working on it for 10 months. That's amazingly short. It's not long. Battery companies have like thousands of scientists working on this for 5 and 6 years. So that's a really quick, actually, that we've been working on this. And we've been working to overcome those kind of structural problems, because we know what the chemistry is. We're really happy with what our chemistry is, but we've been working to get these kind of stupid, dumb constructional problems sorted out. Because if you don't sort them out, by the time you're going to build a big device and you get one fail in there, you're not going to know what it is. And you'll have just spent months making the damn thing. It's going to be really upsetting. So taking care in the construction and making sure you're constructing it right is what you want to do when you're going from the little bit to the big bit. And it helps to go through that 1 centimetre to test your chemistry, 10 by 10 to test your structure, and the big box to really do something that you want to do. Now we obviously take our base electrode, and that's the base electrode material there, give it a clean, and apply the active material to it. What I'm doing now is looking for a piece of active material for you, so I can show you what that looks like. That's not it. Where did I put that? Oh, maybe that is it. It's been pointed to me off camera. Thank you. Here it is. Hanging up, trying. That's a bit of the electrode now that is coated with the battery active material. Now this is beautifully thin. I mean, when we look at that, we can actually see straight through it. Now we're very interested in thin film designs, so we tend to put this on in a thin film. That's just our bent. We need to do something about thick film, but at the moment we're really interested in thin film, so we tend to do thin film designs. So that is one of the electrodes that's in that black box, all nicely coated up now. And all we do is slap on a bit of a separator and lay the opposite electrode up, and hey presto, we've got a very nice neat cell. We can make this in a 10 by 10 or a A4 size, and as equally easily. It's the same structure and construction that we use to do that. And that obviously gives us a cell with 2 nice little tabs sticking off. And we can put that in a little baggie and fill it with electrolyte, and there is a basic cell. Now if you want to make up something with a higher voltage, obviously, all we do is make these cells up with sufficient area for the amperage that we're looking at. These, remember, run at about 2.4 volts, and we need 6 of those to make a 12-volt battery. So all we actually do is pouch them up with enough material parallel to create the amperage that we want, and then connect them in series to create the voltage we want. So what's in that black box is a whole load of those, A4 size, some connected up in parallel, where they've got about, I think it's 50 sheets per unit. We put 50 sheets together and crimp those together. And then we have, I think it's about 20 of those packed up, put in series to get our output voltage with the output amperage that we want. So effectively, that's how we actually go about making these batteries, making the larger size batteries. The thing to take away from this is care with construction. Your battery is going to rely much more heavily on the construction of it rather than the chemistry of it. In the next video, what we're going to do is have a look at 3 types of these batteries we've been working on. So we've got a very inexpensive baseline battery that's effectively a supercapacitor, but we're quite pleased with it because it has roughly the same energy density as lead acid. Then we're going to look at battery chemistry number 1, which is kind of a midpoint one, and then battery chemistry number 2, which is actually the plate I just showed you. This plate here is battery chemistry number 2. That one is the one that has fairly astonishing. In fact, that one I think is about 350 watt-hours per kilo. And we'll show you the discharge curves on them in the KDEX and talk a little bit more about the KDEX problems and how to go from that simple testing that we were doing when we were running a variable load on a meter and getting an impression to the more complex testing where we're using a fixed calibrated load on the meters to get a good picture of where we are with the energy density of the battery. Anyway, I thought that was of interest, and thank you very much for watching.